This video is going to focus on pages 1 and 2 in your angle relationships and triangles packet for Unit 6. So we're going to start at the bottom of page 1, and we're going to first review the types of angles. So these should be somewhat familiar to you, but it's been a little while since you've worked with these, so that's why we're going to review what they are. So the first angle that we're going to focus on is an acute angle. So an acute angle is an angle that measures less than 90 degrees. So you want to go ahead and get that written in. So again, an acute angle is smaller than 90 degrees. The next angle that we're going to focus on is our right angle. And our right angle measures exactly 90 degrees. Those are those angles where if you have kind of what looks like an L and you see this little box here, that tells you that that's a 90 degree or a right angle. The next angle that we're going to focus or review is an obtuse angle, and an obtuse angle measures greater than 90 degrees or actually but less than 180 degrees. Okay, so an obtuse angle measures greater than 90 degrees, but less than 180 degrees. And then our final angle that we're going to focus on, which probably is new to you, is a reflex angle. So a reflex angle is greater than 180 degrees, but smaller or less than 360 degrees. So a reflex angle looks something like this, where if you had an angle kind of like this with a 90 degrees, your reflex angle would be the one that kind of goes around the outside, where it's greater than 180 degrees, but it's smaller than 360 degrees. So make sure you have that written in on your notes. We're going to move on to page 2 now, and on page 2 we're going to focus on the types of angle relationships. So the first type of angle relationship that we're going to focus on are called adjacent angles. So if you think about the word adjacent, that means that we are side by side. So if you're adjacent to someone or you live adjacent to someone, that means that you're right next to them. So our definition for adjacent angles would be angles that share a common side and vertex but don't overlap. So for example, if you take a look at the picture, you'll see that first of all, a vertex is the point where two rays come together. So S would be considered a vertex. So it's that common point. And then sides would be those rays. So again, if you take a look here, we have this OSN. So that's how we would name that angle, would be angle OSN. We always have the vertex in the middle. And then our next angle that would be adjacent to angle OSN would be angle NSI. So angle NSI would be adjacent to angle OSN. Notice that the reason why is because they share that common vertex and they share this common side of the line N. Okay, so that tells us that these angles right here and here are adjacent because they're side by side. The next type of angle relationship that we're going to focus on is a complementary angle. And a complementary angle is an angle or angles with a sum of 90 degrees. So if you can add two angles together and get a sum of 90 degrees or make a right angle, those are complementary angles. So again, in our example, you can see that with angle A, which I just highlighted in yellow, that's part of a right angle, and then angle B is another part of a right angle, and when we add angle A and B together, we get a 90-degree angle. So again, complementary angles are angles with a sum of 90 degrees. Two more types of angle relationships. The next one is called a supplementary angle. So this is similar to a complementary angle, except for the fact that the sum of supplementary angles, so when you add those two angles together, you get a sum of 180 degrees. So this makes a straight line now. So if you look at our example, you'll see that we have angle A, and that would be considered an obtuse angle because it's greater than 90 degrees. And then we have angle B, which would be an acute angle because it's less than 90 degrees. But together, if we add angle A and B together, we get a sum of 180 degrees, making them supplementary angles. So that would be their relationship. The last type of angle that we have are called vertical angles. And vertical angles are simply just angles that are opposite of each other when two lines cross. So in this example, you can see that we have two lines that intersect here and here. So if we take a look at those two lines that intersect, we have angle A here and this angle A as well, and these are actually equivalent or equal to one another. So vertical angles are also equal to one another or congruent. So if we think about the word congruent, congruent means equal. So each pair of vertical angles are congruent or equal to one another. So make sure you have that written down. So again, in this example, we know that angle A, or these two angles A and A, are congruent or equal to one another. And we also know that if we take a look at the B, the angles that are labeled B, those are considered vertical angles, and those are also equivalent or congruent to one another. So make sure you have those examples written down. So we want to be thinking about, why is this important? Well, this is important because we are now going to be able to use the idea of our angle relationships to write and solve equations in order to find a missing value. So for example, if you take a look at example 1, you're going to notice that we have an angle that's labeled 45 degrees and we have an angle that's labeled 3x. Well, we obviously don't know what the x is in 3x, so we have to figure out what that equals. You want to be thinking about, what is the relationship between these two angles? Well, if I look here, I notice that I have a 90-degree angle. So what that tells me is that these two angles are complementary angles. So we want to go ahead and write that down, because the more that we practice the vocabulary, the more comfortable we are going to get. So these are going to be complementary angles, which means that they are equal to 90 degrees, which we can recognize because of the 90-degree symbol there. So the way that we can figure out what 3x is equal to is that we know that our equation is going to have to be equal to 90 degrees. And what I mean by that is, when we take the 45-degree angle and we add it to 3x, we have to equal 90 degrees. So that's going to be the other side of our equation. 45 plus 3x equals 90 degrees. We're going to go ahead and solve this just like we would any other two-step equation, like in our last unit. So we're going to draw our line down through the equal sign. Remember, we're using reverse order of operations, so we want to get rid of that 45 degrees first. So we're going to subtract 45 on both sides, and we get 45 when we do 90 minus 45. We have a 3x left on the left, and now we're going to isolate the variable or get x by itself. So in order to do that, we need to divide by 3. Once we divide by 3, we figure out that x is equal to 15 degrees. So now that I know that x is equal to 15 degrees, I can take that information and substitute. So I can do 3x, or 3 times 15. And that tells me that this angle, the missing angle, is also equal to 45 degrees. So make sure you have that written down. Now we're going to take a look at example 2. Example 2, again, we have two angles. So we have angle ABD and we have angle DBC. Again, we need to identify what is the relationship between the two angles. Well, if I notice that if I take these two angles and I combine them together, they create a straight line, and that straight line is equal to 180 degrees. So that tells me that the relationship between these two angles is a supplementary relationship. So they are supplementary angles. And if I look back or think about what does a supplementary angle mean, it means that the two angles must add up to equal 180 degrees. So that tells me again that my equation must be equal to 180 degrees. Since I know that, I now know that if I take x plus 5 and add 120 to that, it has to equal 180 degrees. Well, the first thing that I'm going to do before I even go to solve is I'm going to combine my two whole numbers together. So when I combine my two whole numbers together, I get x plus 125 equals 180 degrees. So once I take a look at that, now I can solve this, and it's actually, instead of a two-step equation, just a simple one-step equation. So I'm going to go ahead and draw my line down through the equal sign, subtract 125 on both sides, and figure out that x is equal to 55. And I'll rewrite that so it looks a little nicer. So x equals 55. So again, if I take that and I substitute it in here, I figure out that 55 plus 5 would equal 60 degrees. So 60 degrees is the measure of angle ABD, and then the measure of angle DBC we already knew is 120 degrees. So example 3, I notice that I have two angles that are opposite one another, which tells me that these are vertical angles. So if I think about the relationship between vertical angles, I know that with vertical angles that each angle, the opposite angles, are equal to one another. So 37 has to equal 7x minus 5. Remember, my whole goal is to figure out what x is equal to. So I'm going to go ahead and solve for x. So I'm going to add 5 to both sides. I get 42 equals 7x. Divide by 7. And x is equal to 6. Again, with vertical angles, I know that opposite angles should be equal to one another. So when I go ahead and substitute 6 in, I do 7 times 6 is 42. 42 minus 5 is 37. Therefore, I know that I have the correct answer for x. So x is equal to 6. Final example, example 4. If you notice that those two angles make a straight line when I look at them together, that tells me that these two angles are supplementary angles. So because they are supplementary angles, that means that they equal 180 degrees. So I can set up my equation of 4x plus 116 has to equal 180 degrees. And then I'm going to go ahead and solve. So now I have 4x equals 64. Divide by 4 on both sides. When I divide by 4 on both sides, I find that x is equal to 16. When I take x and I substitute it back into 4x, and I do 4 times 16, I figure out that this angle would be equal to 64 degrees. So make sure you have all that written down on the first 2 pages of your packet, and then we're going to do some practice.